Welcome back to my channel. I am back with another video on integration. So in my video today, I am going to look at the integrals of sine and cosine functions only. And before I move on to the integrals of these trig functions, I'm going to do a quick recap of derivatives of trig functions. So everyone knows that the derivative of sine and cos is given. So derivative of sine is cos x and the derivative of cos is negative sine x. If you have a function sine ax plus b, then we can make use of the chain rule. So that's where we find the derivative of the outermost function first and then multiply by the derivative of the innermost function, so the chain rule. Similarly, to find the derivative of cos ax plus b, you have a negative, and then once again using the chain rule, you get a sine ax plus b. So in this lesson, in this video, we are going to integrate all of these types of functions. So to find the integral of these functions, the integral of cos x is positive sine x. The integral of sine x is a negative cos x. The reason being, when you derive the sine x, you get a positive cos x, and when you derive the cos x, you get the negative sine x. So which is why we've got those negative signs, that negative sign there. Now, if you have a function cos ax plus b, so you can see that the argument there is ax plus b, that gives us 1 over a sine ax plus b. To solve questions like these, there's something called the substitution method, which is a very reliable method, mainly used in specialist maths. Methods students do not have to use it as often, but it's a very good method, very reliable method. So what I'm going to do is I'm going to replace this as a letter u. So let the letter u represent ax plus b. Now I'm going to derive u with respect to x. That gives us just a. If I rearrange this and make dx the subject, dx is going to be 1 over a du. So I've got my u and I've got the value for dx. So cos ax plus b now becomes cos u. Dx becomes 1 over a du equals 1 over a cos u du. So that is, what's the derivative, integral of cos u? That's sine x. So 1 over a sine u plus c. 1 over a sine ax plus b plus the constant of integration. So that's the proof of that rule. Very similarly, you can replace the ax plus b as u here. And then you end up with a negative 1 over a. So moving on to some examples. Cos 7x. If you want, you can use the substitution method here, but that's not needed. So some people might want to see how we get to the answer. So let u be equal to 7x. So du over dx becomes 7. I can write dx as 1 over 7 du. So now cos 7x dx is, so what was our 7x? That was u. So cos u dx was 1 over 7 du. So 1 over 7 cos, the integral of cos is sine. So sine u plus c, or I can rewrite that as 1 over 7 sine 7x plus c. So in methods, you're not required to show this. You're not required to show the substitution method. In specialist maths, you would be expected to show that method, especially if the question asks you. You may memorize the rule as it is and apply it in methods, which is acceptable. Part B of the question, the 8 there has nothing to do. I mean, it won't affect our calculations much. So it can stay outside while we maybe use the substitution method or not. So that can be written as 8. Now, the integral of sine is negative cos. So negative cos 16x plus 3 divided by 16 plus c. So that's equal to negative half cos 16x plus 3 plus c. If you were to use the substitution method, then you would substitute u as 16x plus 3, and then du over dx would have given you 16. Therefore, dx would have been 1 over 16 du. And then you substitute it here. So that's 8 sine u, and dx would become 1 over 16 du. So that would have given you 1 by 2 minus, because it's negative, integral of sine is negative cos, so cos u plus c, so negative half cos 16x plus 3 plus c. So you've got the usual method, and that's the specialist maths method. Up to you, whatever method you use, you won't be penalized. Okay, moving on to our last example. This looks complex, but it is not. So we are going to rewrite this in this form: 1 by 8 x minus 5. So if you want to use the substitution method, you can go ahead and do it. Otherwise, you just go 3 by 4, and that's negative cos 1 over 8 x by 5 divided by 1 over 8 plus c, and that can be rewritten as 3 by 4 times, let me place the minus sign there, 8 over 1 cos 1/8 x minus 5 plus c, and then finally we simplify that, so that's negative 6 cos 1 by 8 x minus 5 plus c. If you were to use the substitution method, you could assume u equals sine, sorry, not sine. Just get rid of that sign there. You don't need the sign, sorry. U equals 1 by 8x minus 5, and then du over dx is just 1 over 8. So what happens to dx? Dx now is 8 du. So that becomes 3 over 4 sine u, and dx is 8 du. So that's 3 over 4 times 8 sine u du. And then that's, I'll just make it a 6 now. And then that's negative cos u plus c. So negative 6 cos 1 by 8 x minus 5 plus c. And that matches our answer here. So thank you very much, everyone. Hope you learned something from my video. Please like this video and subscribe to my channel. Thank you very much. See you soon. Ta-da!